Hello, this is Joe Neville, and in this video we're going to look at how to interact with the Aruba Central API programmatically. So no more juggling tokens or copying and pasting files around. We're going to use a much more efficient method that's using code to automate and get the job done. Let's get into it. Here's the agenda. We're going to start off high level, talking about the different approaches to logging into Aruba Central API and getting data from there. Then we're going to go a lot deeper. Now that's because Aruba Central uses an OAuth 2 framework for authorization. And this can be a little bit tricky if you haven't come across this before. It's certainly something that I struggled with to start with. I'm going to be looking at the theory and then how that theory is applied in the case of Aruba Central so that we can really understand what's going on with the authentication and the authorization and confidently move on to interact with the API programmatically. And I'm going to show you a demo of some code. It's some Python code which we pushed to the Aruba GitHub, and you can clone down yourself to interact with the API, sending API calls, receiving data, but also handling the token exchange. So the generation and the refresh of the token, all you have to do with the workflow is enter your password at the start. And once you've got the tokens, you don't have to worry about that again. The code itself can refresh the tokens for you. So you just run your API calls. Let's start off with the first topic then, logging into Aruba Central API. If you're new to Aruba Central API, your first step should probably be logging into the Swagger interface. Now, Swagger is a popular graphical user interface that sits on top of many REST APIs, and Aruba Central is no exception. So this gives us a way to interact with the API and get our bearings, kick the tires, as I've said here. And the standard process is to use the Swagger interface to examine it for the URLs that we need to send our calls to, and then we can see the data that we get back from the API. Then we move on and we translate that to, and I'm calling this the standard approach, which is to interact programmatically. So we're using code to send HTTPS calls to the API, and then we will receive our response data and we use code to do something with that data. Let's jump in and have a look at the Swagger interface then. Here I am on the standard Aruba Central GUI. I'm at the overview level. Now to get to the Swagger interface, we go top right and hit this icon here, which is labeled Account Home. And then that takes us to this screen, and it's bottom left for the API gateway. And then what we need to do is, because we need an access token to get any data from the API, we go to My Apps and Tokens, hit this here, Add Apps and Tokens, select, I've just got Network Operations, so I select that, Generate. There's a slight delay there while this is generated, so only hit it once. And then we have a token. Now so we've got the option to revoke the token when we finish. We can download it, which I will do. And you can see here, so we've got an access token and we've also got a refresh token. We're just going to use the access token. So I'll copy that to my clipboard, go back. Now we need to go back to the API, and then we hit, you can see there, Swagger. We hit that link to be taken to the Swagger interface. And here we are for the Central API. It's divided into 3 columns. We have a selection here of the different APIs and the URL families. In the middle, we have the actual URIs, and we have details about them, things like parameters, and we can try a specific call. And then over on the right here, we have the response data. That's given us what we need to investigate the API. We've got the different calls, we've got the specific data about the URL calls, and then we've got the information about the data that's going to be returned. But this Swagger interface allows us to play around with it, and this is live, so the data that comes back is actually from my central account here. Let's pick one. So if we go to the URL, I've been calling it URI, URL. Normally those phrases are interchangeable. If I select, we've got some on here. New device inventory. That sounds interesting. What we do is we paste that token in and we hit this button here to apply it. Then let's go get devices from inventory. And so we have, this is a get call to get information. This is a bit like a show command. We have various parameters. I'm just going to leave those as defaults, except for this one, which is labeled as required. So that's a string. We have to put in whether it's an IOP or an MAS. So that's a switch or an AP. I'm going to go with MAS. There we go. And I'm going to try it out. There we are. We've got a pop-up with the information. We've got the request URL, so that's the really vital information that we would put into our code, and we've got the response data. As you can see, that is actually the devices that I've got on this account. We've got the part number, device type, MAC address, model. What we can do then is we can just check that this URL is giving us the information that we require, but not only that, it's giving us the format. So you can see that it's curly braces there, so that's going to be a dictionary. If we put that into Python, we've got a key, and then we've got the square brackets there, so that's going to be a list. So it's a list of dictionaries. If you know your Python data types, that's the kind of thing that you're going to need to put into the code to pick out the desired data. Looking back at our steps, we've covered off Swagger. Fine, let's tick that off. Now, moving on to a much more standard approach for interacting with APIs, and that's programmatically. But to really understand this, we need to dive into OAuth 2.0. So let's do that now. As someone that's done a lot of work with IPv6 recently, I love myself an RFC. Who doesn't? Well, OAuth 2 has an RFC, it's 6749, and here is a quote from that, which I think really gets to the heart of one of the key issues with this framework. So here's the quote. OAuth 2.0 authorization framework enables a third-party application to obtain limited access to an HTTP service. Well, the HTTP service, so that's our API. Okay, for the pedants out there, we're using HTTPS, but you know, you get the point, I hope. Now, what about this though, the third-party application? So as networkers, we're used to with SSH or, you know, Telnet in the past, using a username and password to log in. And if you've used APIs such as the AOS CX API, you use a username and password for that. But this framework is different because it's the application and not the user that logs in. And there's really good reason for that. Okay, here is an emoji graphical representation of a kind of legacy approach. So we have the user and we've got a script that we're going to run against the API, which is my_script.py. So it's a Python script. Obviously, it can be anything. And over on the right here, we've got the API. What do we do then? Well, the user has a username and password, credentials, that we put into the script. And so the script is imitating the user when it logs in. It's not the user going directly, it's the script using the username and password credentials. So bear that in mind. That's really important. There's a number of reasons why imitation isn't great for your security policy. I've picked 3. First one being that there's no separation between the user and the app. So you don't know when you're auditing whether it was the app and maybe someone else running the app or the user that you can see in the events. Not good. Next up, I've got that the app has access to everything that the user does. So you can't have any granularity of authorization for the application. It's either got access or it hasn't. And finally, you can't revoke the app's access without changing the user password. Ideally, if you're dishing out access to an API on your behalf, you would want it to be really easy to revoke that access. Well, it's not. You've got to change your own password. And for these reasons, and many others, OAuth 2 uses delegation rather than imitation. Let's go through the exchanges which form the OAuth 2 framework. Now, I've copied this straight from the RFC. I've added some colourful boxes and an emoji. Now, okay, so what we have is we've got 4 main components. Over here, we have the client or the application. I'm going to use that interchangeably. That's the thing that needs access to the API. Over here, we have the resource owner or the user. So that's the entity that holds the username and the password, the access to the API. That's the entity that can pass authentication. Next up, we have the authorization server, and that's the server that's going to authorize the application, everything being good, to have access to the final piece of the puzzle, and that's the API. Let's go through the exchanges. First of all, we have an authorization request that goes from the application to the resource owner. And if that's successful, the resource owner sends back an authorization grant. And this really gets to the heart of it. So it's not the resource owner that's logging in directly to the API. The application is logging in on behalf of the user. So this is where we see this separation between the user and the application. The application asks the user, can I have access to the API? Can you give me an authorization grant? And if the user wants to, they send back an authorization grant, which the application uses to interact with the authorization server and say, look, I've been granted access to the API, and the authorization server sends back the access token and the refresh token. So the access token being like the swipe card to get through the security gates of the API. And finally, the application uses the access token. It combines the access token with its HTTPS calls to allow it access to the API resources, and then the protected data is sent back to the application. So the key point being, it's not the resource owner that's logging in directly to the API, it's the application on its behalf. And the resource owner has to grant that application authorization to do so. That in principle is the high-level exchange. Now let's see how this high-level framework applies to Aruba Central. And this is for a new workflow. That's really important. This is where the application has never had access to the API before. Okay, so a new workflow. Before we start a new workflow, there's some information that we need to gather together. Here's what we need. First of all, we need some basic user information, such as the customer ID, the base URL, that's the URL to log into Central, and we need the username and the password of the user because we're going to authenticate for the first time and essentially delegate to our application. And we need information for our application. I'm using the term application or client interchangeably here. And the data that we need for the application is the client ID and the client secret. That allows the application to identify itself, and we get that from the app registration process, which we'll go through in a moment. We can get all of this information from the GUI. So let's go there now. Here I am back on the GUI. I'm at the API gateway. So let's collect the required information. For the basic customer information, I've already got the username and the password, of course. And please note that you need to use a user which is not utilizing single sign-on, because it's just a traditional username and password for the authentication for the first time with a new workflow. Now we can get the customer ID from hitting this figure up here. Customer ID will appear. The other thing, we need the base URL. Now that's for your central instance, so it may be different from the URL you can see on screen here, depending on where your central instance is housed. And what we do, the base URL is the first part of the URL, and then we add the API suffixes to that, and it ends with .com. So you concatenate that, take off Swagger and beyond, and that's your base URL. Now we need to go through the app registration process to get that client ID and the client secret. Hit System Apps and Tokens. Then add apps and tokens. Give it a name. I'll call it My App 1. Select network operations, generate, and then we get the client ID and the client secret. Record those down and remember to keep those secret because they are like a username and password. You know, it's sensitive information because you're going to delegate authorization to the application and it will have access to your account. Now, in this process, you do generate a token, but you don't need the token at this point. What we're looking for is just the client ID and the client secret. And I've written up how to create a new application, essentially that process. It's all in the README of the API tutorial, so you can see I've got diagrams there of where you need to click, what to record, etc. I will put a link in the description. Now that we've got the required information, let's have a detailed look at the central authorization workflow in action. So we're back here with our four entities, our client or application, our resource owner, the user, our authorization server, and our API. And when we're thinking about Central, I believe it's better to think about the authorization and the API as a single entity, because you're just sending to the base URL of Central for your authorization and for your API calls. It is different suffixes, but in this case, it's not like you're sending off to two completely separate servers. So I've combined those two as a single entity that we're firing our API calls to. And if you think about how the OAuth 2 framework started, it started with the application asking the user for an authorization request. And when OAuth 2 is applied to web applications, that's what you see. But with the workflow that we are looking at here, I don't think that's a very useful approach. So the way that I've illustrated it is that the login request, which is what we're going to send, comes from the user. We put it into the application, and then we send our details to the authorization server, to the API, in a login request. On screen, you can see the base URL, so that's our central URL, and then we've got this to login, okay? So that's why I've called it a login request. And the information that we send in that call, in that API call, is the client ID, so the ID for our new application, the username, and the password. That's our authentication on behalf of this new application. We're essentially registering it with the authorization server there. And if that's successful, the server will respond with a session cookie response, okay? So what you've got in there is you have a couple of tokens that we require for subsequent calls. There's a CSRF token, which is a cross-site request forgery token. That's a process that OAuth 2 helps to mitigate. We won't go into too much detail there, but essentially you've got two tokens, one for CSRF and one for the specific session. And with those tokens, the application then sends back, so this is our next API call to Central, now to a different URL. This is for the authorization request. And what we have is the base URL plus this OAuth 2 authorize Central API that we're sending it to. And the information that we send is we send those two tokens back plus the customer ID plus the client ID. So we're tying the session itself, the customer that's authenticated plus the application for our authorization request. And if that's successful, then the authorization server sends back an authorization grant, which is an authorization code. And then the application includes that authorization code in its next call, which is the authorization grant. So we're sending to a different URL again with the suffix OAuth 2 token. And this time we have a grant type of authorization code, because that's what we've got. We're telling the server we've got an authorization code. Here's our authorization code. And here are the details about the specific application. So the client ID and the client secret, those are included in the API call. And then finally, we have the token grant. So this is what we're really after. This is where we receive the access token and a refresh token from the authorization server. And that's like our golden ticket to get the data from the API. Plus a refresh token that we're going to use for subsequent workflow, so we don't have to authenticate with the username and the password each time. And for programmatic workflows, what we do now is we take the refresh token and we store it somewhere. The reason for that is that the access token has a limited lifespan. It's just 2 hours, whereas the refresh tokens is a lot longer. And what we can do for subsequent workflows, we can just take the refresh token, refresh our access token, so we can skip the authentication steps. We don't need the username and the password. But one thing that you should realize is that the refresh token is sensitive information. You should treat it like a username and a password. Don't be putting it on a post-it note and sticking it to your screen, because it allows the holder to refresh the access token and thus gain access to your central account. Now, in the Python workflow that I'm showing, it is just for educational purposes, big caveat, because I am writing the refresh token to a clear text YAML file. So don't run the workflow and then be on a Zoom call or screen recording or do this on a shared resource, okay? Big warning signs. The refresh token is sensitive information. And this is interesting because it opens up a market for new products which are focused specifically on the storage and retrieval of API keys. For example, Azure Key Vault or HashiCorp Vault. And I'll be going into details of those in later videos as we get more serious with our workflows and getting them production ready. But for now, refresh token, save that somewhere safe. Because we're on the last stage actually. What we're doing now, we've got our access token, and then we can make our API calls for the information that we want. So we add the base URL and the specific API call that we've probably got from Swagger, and we combine that call with our access token. That's our admittance to the account. And if all is successful, we get back our data. You know, and steps 9 and 10, etc. are doing something with that data. Right, that's a new workflow. So that's the full end-to-end workflow when you haven't authenticated an application. What about a refresh workflow where we do already have a refresh token? With the refresh token in hand, we can skip the authentication and the authorization grant and go straight to a refresh token call to this specific URL. So it's base URL OAuth2/token. The grant type is refresh token. We include the client ID and the client secret for identification of the application and the refresh token. If all successful, we get back a new access token and a new refresh token. We save off the refresh token as we did before, and we carry on with our all-important API calls to get the data that we require by combining our calls with the access token, which is good for 2 hours, remember? And then we get back what we're all interested in, the data from our API calls. So as you can see, it's a much shorter process. Obviously, when you're doing this programmatically, it's all going on in the background. But the key point being, with the refresh token, the username and the password and the authorization grant, that's all out of the picture. We just go refresh, get the new tokens, do our API calls. Now let's have a look at a new workflow and a refresh workflow in Python. Once again, all the code for this is available on the Aruba GitHub. It's under Central Examples Only, REST API, Python scripts, and it's the API tutorial that I'm going to show off here. Here I am in VS Code. I've git cloned the Central Examples Only repo down to my local machine, and I'm looking at the API tutorial. So for this, what I've done is I've presented the code, which is functionally the same, by presenting it in 3 ways for those people that are really just getting to grips with Python and might not understand things like Python classes. So if we were going to go through in order of difficulty, I'd say you start with central_global, which everything's just in global. Then we've got central function, where I use functions, and finally central class, where I use classes. Now if we look at global, we've got 2 scripts there, full authentication and refresh. If I show you full authentication, I put a big caveat, big warning at the top there, do not share this because the variables are declared at the top, to try to make this as quick and dirty, as simple as possible, so you can get to grips with the calls rather than what Python's doing, okay? So, and this is where I got the information. So as you can see, we have the different calls which I've shown in the slides already. So we've got the login call, which needs the client ID. We've got the username and the password there. Then we get back the session and the CSRF from the cookie. We need to take that and combine that into our next call, which is the authorize API call, which goes to this URL, and we include that session token and the CSRF token, plus the customer ID and the client ID. Then we have the authorization code call here, and from that we pick out the refresh token and the access token, writing the refresh token locally. And then just to show off an actual API call, I do a call to get details about the AP. So that's the standard API calls, which I've already covered in code. Now, if you were going to run that, that's for just full authentication. And when you've got a refresh token, you could run refresh, which has just the grant type refresh token call, and then the subsequent API call for the AP information. Now that is the most quick and dirty, as I've mentioned. So for this example, that I'm going to go to the harder one, which is the central class, and that's the one that I use. And with this, what we do is we take our information. I'm not going to show my variables on screen, obviously, for security reasons. So the original file looks like this, where we populate, this is a YAML file, we populate it with those required pieces of information: client ID, client secret, customer ID, username, and the base URL. Oh, and I should mention, I was going to show you an example of a base URL. If you're wondering what that looks like, well, there's the one I'm using for my calls. Here's central class then. I'll just step you through that, and there's a bit more intelligence in this than central global or function, because, and that's why I use it for my examples, because it checks to see if there's a refresh token in the local directory. If there is, it just runs through the shortened process with the refresh token. And if there isn't, it runs through the full process needing the authentication and the authorization. So you need to input a password at the beginning. So I've got various methods here for the different steps that we're taking, like reading from the YAML file, the login call. Here's the login call. We've got authorization, the different token calls, etc. And then at the bottom here, I've got a get call. So this is the call to the API to get that important data for us. That's what this is all about. And I've tweaked it a little bit so that I'm not printing too much data about my own account to screen here. And I'm just going to print out from my APs the model and the firmware that they're running when I run that. Okay, so to run that, let's jump over to the terminal. Here I am on my terminal. I'll just do an ls for you. So I've got my central underscore class. I've got my vars.yaml. I've still got the vars underscore original because I wanted to show you the original file, but I have populated the vars.yaml with all of the information that's required, the client ID, the client secret, etc. I'm also running a Python virtual environment so that I have all the necessary packages installed. And you'll notice that there's no refresh token in this local folder, so it will run through the full authentication and authorization process. So I type out Python central, tab that. Okay, now there's no refresh token, so I need to enter the password for my user. Login successful. We make the API call for the AP, and I've parsed out the data for the model and the firmware to emulate something that someone in operations might do and might want to automate. And also you can see that message there that we have written the refresh token to the local directory. If I do an ls on that, you'll see the refresh token. Remember, that's sensitive information, so don't go sharing that. If I up arrow and run central underscore class again, notice that I don't have to enter the password here at all. Okay, so we're refreshing the refresh token and we get the data that we require. So we're interacting programmatically with the Aruba Central API, and we don't require username and password or the full authorization flow. If I up arrow again, you'll see, so we can bundle multiple API calls together. We don't have to worry about the access token anymore timing out after 2 hours. We just need this Python workflow and the refresh token. Okay, that's it for getting started with Aruba Central API. So the three things that we did: we looked at the general approaches for logging into the API. We delved into the OAuth 2.0 framework, and I put a lot of animation in my keynote slides. And then finally, we brought it all together with a Python workflow using the code that is posted to the Aruba GitHub. Where I'm taking this next is quite interesting, I think, because we are going to think more about how to deal with those API keys, how to store them and how to retrieve them. I've got a demo that I've been working on interacting with HashiCorp Vault for those very such purposes. That's in the next video. Please like, comment, subscribe, all of those good things. I hope you found this video useful, but that's it for now. My name is Joe Neville. Thanks for watching and goodbye.